Hi everyone and welcome to my signature course on Exponents and Indices 101. You are getting a snippet actually of this course with all my past paper solutions. My videos actually of my past paper solutions are going to be made available and free for you on my YouTube channel. I'm also on Facebook and on Instagram. Now, if these solutions were not enough, if you think that you need some more practice, I recommend that you click the subscribe button below this video and join my email list, and you will be on your way to receiving all my special packages for Christmas. I'm going to have specials on my course, and in this course, you will be exposed to all my customized videos, worksheets, assignments, quizzes, everything that you need to master indices for CSEC Paper 1 and Paper 2. I am so excited to have you. I'm so excited to be launching this academy, and I hope that you join me. Basically, we simplify math at every level. For CSEC, our motto is determined to improve, driven for excellence, and passionate for success. Now, for the first question on our agenda is the January 2020 Paper 1. Question 2, it is -2/3 all to the power of -2 is equal to. Now, next to that, this is a popular repeated question. Now, all questions in Paper 1 are popular and repeated. Okay? All right, so we have -2/3 all to the power of -2. Now, the law or the rule of exponents that we are going to use, or the law of indices that we are going to use for this one, the law states that x to the power of -n is equals to 1 over x to the power of n. So that basically means that anything to a negative power, you put 1 over that. So if we had 2 to the power of -3, you simply put you simply put 1 over 2 to the power of 3. If you had, let's say, x to the power of -p, you simply put 1 over x to the power of p. So in this question, we have -2/3 all to the power of -2. So you are putting 1 over everything. So that's 1 over everything. And what is everything? -2/3 squared. Now note the negative sign here. We did not put the negative sign, right? You do not put back the negative sign, right? So this is equals to 1 over, now you know anything squared means you're multiplying by itself 2 times. So -2/3 squared simply means you're multiplying -2/3 by itself 2 times. So that's -2/3 multiplied by -2/3. So that's 1 over, a negative and negative is a positive. So this becomes a positive. 2 2s are 4. And 3 3s are 9. 1 divided by 4 over 9 is 9 over 4. Wonderful. So now we are on the May June 2019 paper, and we are on question 26. So question 26 says 3x squared multiplied by 2x cubed. Now this is similar to the question we did previously. First, we have to multiply the coefficients, and the coefficients are the numbers that are in front of the unknown variable. All right, so the coefficients in this question are 3 and 2. So you are going to multiply 3 multiplied by 2, which is 6. And now we're going to work out what is the index for our variable x. Now, when we have indices of the same base, just like the one before, same base meaning here and here are the same, right? So when we have indices of the same base, you have to add the index, right? So that's n plus m. So we have x to the power of n plus m. So basically you have x squared and you have x cubed. So you're adding 2 plus 3. So that's 6x to the power of 5. That is b. Moving on. This is the January 2019 paper 1, question 21. This question is of the same nature. The question says the product of -2a and 3a is. Now product means to multiply. That becomes -2a multiplied by -3a, because we want the product of this and this. Remember, product means to multiply. That's -2a multiplied by -3a, just like before. What we do, we multiply the coefficients and then we work out the index of those that have the same base. That leads us to -2 multiplied by -3. A negative and a negative is a plus, and 2 multiplied by 3, 6. So we end up with positive 6. Now we need to figure out what is the index for A. It is understood that A is to the power of 1 and A is to the power of 1. Therefore, we have to add the two powers because we are multiplying. Remember, when you are multiplying, you add the powers. That leaves us with 6A squared. And that is D. Wonderful. Moving on to the next slide. 2018 paper 1, please do not let a question like this get you confused or frightened in the exam. You take your time, you read the question, understand the question, and I'm sure you can work it out. So here goes. We have 6 multiplied by 10 to the power of a negative n is equals to 0.06. They told us that n is great. Oh, sorry about that. Okay, they told us that n, why is it looking like that? That is the ugly n. They told us that n is greater than 0, and n could either be 1, 2, 3, or 4. What can we do? Simply, you plug in 1, 2, 3, 4, and whichever one you plug in as n, that gives you the 0.06 is the answer. Okay? So let us do that. So let's try the first one first. N is equals to 1. So let's try n is equals to 1. Let's put an if there. If n is equals to 1. So we have 6 multiplied by 10 to the power of negative. So instead of n, remember we are trying 1 first. So instead of n, we are putting n is equals to 1. 6 to the power of negative 1. Remember, the negative sign stays. We are entering a value for n. That becomes 6 multiplied by, remember the law of indices, x to the power of negative n is 1 over x to the power of n. Therefore, 10 to the power of negative 1, you put 1 over everything. Anytime you see a negative power, you put 1 over everything. That's 1 over 10. Right? 10 to the power of negative 1 is 1 over 10, right? This is equals to, of course, you put your 6 over 1 because it is a whole number. 6 multiplied by 1 is 6, right? 6 multiplied by 1 is 6. And 1 multiplied by 10 is 10. When we are changing a fraction to a decimal, wherever you see the, okay, so the 6 lines up with the 0. Right. The 6 lines up with the 0, and the 1 lines up with nothing. Wherever the 1 lines up, you put the point. That's how I learned it in primary school. I assume it's the same way now. Right? So therefore, it becomes, instead of the 1, you put your point. So that's, instead of the 1, you put the point, and you get your 6. You put the 0 in front, so that's 0.6. Now, that's not what we have. We have 0.06, not 0.6. So therefore, 1 is not, n is not equals to 1. So let's try 2 now. So let's see. If n is equals to 2, we have 6. We have 6 multiplied by 10 to the power of negative n. What's going on today, boy? Right, 10 to the power of negative n. That's 6 multiplied by 10 to the power of negative. Remember, instead of n, we are putting 2. So that's 6 multiplied by 1 over 10 squared. Just going to write this on the side, right? That's 6 over 1 multiplied by 1 over 10 squared means 10 multiplied by itself 2 times. That's 10 multiplied by 10. And we know that 10 multiplied by 10 is 100. So instead of 10 multiplied by 10, I'm just going to put 100 there. Working out your fractions, you multiply the numerators, you multiply the denominators. 6 multiplied by 1 is 6. 1 multiplied by 100 is 100. Now look at this, right? We have 6 over 100. The 6 lines up with the 0. Now this 0 has nothing lined up with it, and this 1 has nothing lined up with it. You put the point for the 1, and you put your 0 to represent that space. This becomes 0 point. There is no space unless I move myself. Right, that's 0.06, which is what we have here. So our answer is 2. N is equals to 2. Okay, moving on. 2018, now we are on to question 25. Now, I did exponents and indices. I did it every past paper question I saw with exponents, indices, I did it. So you can find indices in computation, which is in the beginning of the past paper. You can find it in algebra, all right, which is more like, no, question 24, 25, 26, around there. So any question with exponents and indices, I did it, right? It didn't matter what topic it belonged to. Oh, it's also part of binary operations. You might find some binary operations with exponents and indices. I did it also, right? So you get more than algebra. So question 25. We have 2 to the power of 6 divided by 2 squared. Now you think about it. Is this question written with the same base, as in is 2 to the power of 6 and 2 squared? Do they both have the same base? Yes, they do. How do we know that? Because it's the same number, right? Remember, so this part here is the base and this is the base, so they are of the same base. It doesn't need to be x or y, right? It's of the same base. Now, when it is of the same base and you are dividing, you have to subtract the powers. What does the rule say? The rule says x to the power of m divided by x to the power of n is equals to x to the power of m minus n. I apologize for the huge handwriting all of a sudden. Okay, that's 2 to the power of 6 divided by 2 squared is equals to 2 to the power of 6, take away 2. You are subtracting the powers. You subtract, well, the index, right? You subtract 6 and 2. When you subtract 6 and 2, great, you get 4. So that's 2 to the power of 4. Now, what does 2 to the power of 4 means? 2 to the power of 4 means 2 multiplied by itself 4 times. I fed up C students. 2 to the power of 4 means 2 multiplied by 4. 2 to the power of 4 is not equals to 2 multiplied by 4, right? Not equal. 2 to the power of 4 means 2 multiplied by itself 4 times. 1, 2, 3, 4. So 2 multiplied by 2 is 4. 4 2s are 8, and 8 2s are 16. Great, let's move on to the next slide. We are almost through, don't worry. This is the May, June 2017 question 26. Again, I have next it repeated. As I said, all questions are repeated, okay? All right, so let's see how fast we can get through this question, but at the same time, take our time. Pink is my favorite color. We have 3x squared multiplied by 2x cubed. Now, this question seems very, very familiar. We did this question before, but we'll do it again, right? Of course, I recommend that you pause the video now, try the question, and then look at the solution. So pause. Now, unpause. Okay, good. So 3 multiplied by 2 is 6. And we have x to the power of 2. Okay. 3 multiplied by 2 is 6. Now, when you're multiplying, you add the powers. Remember, when you're multiplying of the same base, you have to add the powers. Oh, that's not a multiplication sign. That becomes x to the power of m plus n. And we have the same base here. The question is x squared multiplied by x cubed. Now I left out the coefficients that were in front of here because we already worked it out, okay? So again, same base, so you add the powers, so you add in 2 plus 3, which is 5. And that is B. B, okay. Now that's pause the video and write. I got that from Adapt Tuition. This is a really, really cool teacher. Pause the video, do the question, and then you unpause. Okay, anyway, big up to Adapt Tuition. This is the January 2017 question 1. Again, it says popular repeated question, but remember, all questions are popular and all questions are repeated. So this question says 2 over 3 all squared. Again, please do not let these questions get you afraid or timid or anxious in exams. You take your time, you read it, you understand it, and you will get through. This question says 2 over 3 all squared. It simply means 2 over 3 multiplied by itself 2 times. How do we know it means that? Because whenever you see a squared sign, it means you're multiplying something by itself 2 times. So therefore, you're multiplying 2 over 3 by itself 2 times. Now, this is basic fractions. If you want me to do a tutorial on fractions, just write a post in the comment section, and I'll try my best. Or you can subscribe, join the email list, get access to my signature course on fractions that is coming out soon. Alright, so 2 multiplied by 2 is 4 over 3, multiplied by 3 is 9, 4 over 9, and that's the easy like school. Okay, next slide. So we are almost through. I know you heard that before, but we really are almost through for this video. Right? Now we have another part to continue the past paper solutions. I didn't want to put all in one video because whenever someone goes on YouTube and they see a video is an hour long or 2 hours long, nobody likes to look at a video. I myself don't like to look at a long video. So I break it up into parts. So the first part may be 15 minutes, 10 minutes, 5 minutes, etc., etc., etc. So you'll be more encouraged to look at the videos and be successful in your CSEC exams. All right?